everyone, how are we doing? Good afternoon, good morning. I don't know what time it is. We're gonna get Mewbot booted back up here. Good to see you here, Matt. Good to see you, KP. Good to see you, Kirsten. Good to see you, Noah and Stevie and William. We got some 201, it sounds like, and we got some 474 doing some functions. We're gonna do more learning on functions today. Knox and Leela, good to see you here. Michaela, good to see you here. Who all is here? Say hey in the chat. Mewbot's waking up. We're gonna start writing down the notes. I think I put them all in the videos. Found out the hard way. But how are you doing this morning? How are people doing? I see questions to start. Let me write them down. Hey, Gabrielle, good to see you here. Okay, can we make a seasonal plot? Seasonal plot was first question. Seasonal plot, that's BAS 475. Seasonal plots. And we have lab 3, question 2 and 5. Did we do one of those yesterday? So, BAS 474, lab 3. Question 2. Here we'll do a second one. BAS 474 Lab 3 mortgage formula. Kind of, I think you posted about it, right? So the biggest thing with the mortgage formula is you want to think about how when someone's paying off their mortgage, it's going down. But also each month there's going to be interest. So you have to calculate kind of monthly. They're paying off. So my question go there. William. I just finished breakfast. Syrup on my hands. Syrup and pancakes right here. No more. They're done. No more pancakes for me. Hey, Rajav. Good to see you here. And Tickle Bell, have some minor issues with assignment 3, 474, and sent on Discord. Yeah, so let me look, Noah. There we go. Oh. It's going pretty, wow. It's taken off like a rocket, right? And I checked it against another online. Wow. Oh, and then you have NAs. Okay, I'll take a look at that. Yeah, I won't run. It looks like you're doing pretty well on this, on the mortgage calculator, on the inputs it takes. No, that's looking pretty good, Noah. And then you have right here, I did it. And I even checked against, nice. That is so good. Noah, do you get that sense of accomplishment? Oh, you're just putting your money in the bank for 500 years. Like you're like Fry on Futurama right there. How do you feel about that, Noah? Yeah. Can you show how to make a plot within for loops? Yeah, that's a big question people are asking about. Let's show about how to make a plot within a for loop. Well, I wouldn't make a plot. I think that's a good thing I can do. Jessica, good to see you here. We might start with that. William said we could. So in 201, if you got questions, so this is homework 3, plots in functions. I wouldn't put it in a for loop. Okay. Let's show that. Make sure, trying to see what I have open right now. Let's show plots within functions. Yeah, no, I'm really proud of you. I'm getting so many random calls today. Okay. Like Pokemon was like, you need to, I don't know. Pokemon wants to update. Whatever. Let's throw out some Mewbot points right here and let's talk about making some plots within functions. I wouldn't make a plot within the for loop. So this is making plots within functions for BAS 474. Michelle, great to see you here. Thank you so much. We're just throwing some extra points for everyone saying, hey, good to see you, Grace and Kevin. Ask those questions in the chat. We are having a Kahoot later tonight for 201, but still 201. Let me know about those questions right there and those pointers. I love it, Shrey. You're cracking me up in the chat. Okay. So think about this. Let's say we want to make a function. I'm trying to think of a function that kind of does like your assignment, but doesn't do your assignment. Let's say we want to make an equation. So let's make a function that simply plots an equation. Does that make sense? So let's go right here and let's go to random normal. Now, what am I doing right now instead of making a function right now? I want to make a function that plots an equation. And so can you do something like, yep, I think KP, we're going to do some of that. Well, I don't want to do too close to it. This is kind of like what we need to be doing. And so I'm thinking of a few ways. The calculation of the mortgage, well, I can talk about that here in a little. Let me do that next, KP. 474. We're talking about how to plot within functions. BS 474, mortgage and calculations. Give some hints on that. Calculations. Okay. Yeah, so I'll show that's I think I can help with that right here, KP. So with this right here, we have an X and Y input. I have a question, what is Kahoot? Oh, it's just a review where we play like a game. It's just a review. It's like a test review, and you do it on your phone. And then when you see when you see a question appear, you hit the button and you see if you win. And it's I ask questions, and yeah, good question, Michelle, right there. Thank you for asking. It's like a fun quiz show game that you play on your phone at 4:30 after I'm done teaching. And then we're gonna do some 4:30, and I've got a meeting, and then it's super fun. Shay, you rock. That's awesome. So watch this. You ready? We're gonna go here to LM, and what does LM stand for? Who knows what LM stands for? Who knows what LM stands for? Does anyone know what LM stands for? Who knows what LM stands for? Probably. Who knows what LM stands for? Ooh, if you're in 201, what does LM stand for? It's regression. That is correct. Linear model. It makes a linear model. And we're now making a linear model. And who knows what these values are? If they're random normal values, these are actually what's. If they're random normal values, and look at how they don't really go beyond -2 and 2. I mean, sometimes we might get a more extreme one, but they kind of bounce around. If we do like 500, we might see a little more variation in them. But they kind of go between maybe -3 and 3. These are what's. These random normal numbers I'm creating are actually what's. Are there any topics on the first side? The regression, a lot of times, regression and normal model, which we're actually combining both of them. Kirsten, 50 points right there. This is actually making a linear model from random z-scores. Z-scores are when we take the center of a distribution and put it to 0, the mean becomes 0, and then a standard deviation becomes 1. So we can actually generate random z-scores, and that's what the function random norm does, is it generates how many random z-scores you want, so you can just make a bunch of random z-scores. So this is something for the upper level classes, but we're also incorporating some Stat 1 topics. Now, if we want to make a function right here out of this, we're simply going to do, and you know what we're going to do. Wait, copy. And so we're going to say F is friends who do stuff together. U is for you and me. N is for anywhere and anytime at all. That's why we make a function. And so now we have our function created right here. And that was from a snippet, which kind of just creates the function for us. It kind of makes the container for it. It's a snippet. And so we're going to call this random regression. That's what we're storing the function into. The function will be stored into random regression. Now I'm going to go here and paste my code that I put inside of here. And I'm also going to highlight all the code and then hit Control-Shift-A to just give it a little nicer formatting. So with this right here, what's the problem with this function right now? What's the problem with this function? What do we need to change? Give me some suggestions or ideas on what I need to fix on this. I'd say there's at least 2 fixes I need to do. What 2 fixes? What 2 fixes? We're talking about how to plot within a function. Sorry about that, swallowed the wrong way. And KP, you're right. Both those are the 2 fixes. I think I'm okay right now. Ay. Return. That's going to end the function right there. And let's go here and say size. Now the size is going to be the size of how many points people want. Does it make sense what this function is going to do right now? Who thinks they understand what this function does? What does this function do? Let's take a look at the random regression function. Take a look. What does the random regression function do? Whoa, that's what random regression looks like. What does random regression do? Whatever I enter into here, I'm entering this into here, that gets put into there, and then it runs this down here and returns the plot. Now, what if I wanted to give somebody a message and say, like, you're this. Let's try this right here. Let's go to cat paste and say you have created a random regression of, and then let's say this size. Okay, do a size and then points. We don't want that's good. And let's run this. There we go. How's this looking? Who's working on, so it's doing a totally random regression, but does this help people who are working on the BAS 474 to be like, okay, okay, I've got a message right there with my input variable. Cat paste can do that. I think I showed that during class, but now you're also returning the plot. So the plot is part of the return, and you also get a message appearing to the user telling them something about what they did. So if you think about this, it's just a random regression creator. So you just run it, clear out everything right here. And the great thing about this is if you gave this to someone, be like, oh, you want to use my random regression creator? You just say, there you go. And it says you've created a random regression of 10 points. So the rest of the code isn't needed. You just run it right here like this, and it does it like that. What are 474's thoughts on this? What are your thoughts? Is it making sense how we're doing this? I don't use return plot, but so yeah, I think it will. I think it'll plot within the function. So if you do that, I like to do it this way. You might be right. KP, let's check it out. 100 points. Probably, because I think it goes to the global environment. I like to do return, kind of ends function world, and I think about that's where it's ending. So let's see, 10 points. Yeah, 100 points again. KP, you're right. And so that's how we're getting it right here. Now, when you think about a mortgage, I don't want to do too much on this. Let's switch. We're going to the next topic. In 201, if you got questions, let me know. 201, drop those questions. We're going to talk a little bit about mortgage and how to calculate that. Okay, so when you buy your house, you typically have a mortgage. Okay. So what's the first thing? Do I need an app to play? No, you just go to kahoot.it. Thank you, Michelle. No app needed, just a phone or a computer, preferably a phone, because you'll go to kahoot.it on your phone, watch on the computer, and play along. Michelle, thank you for asking. Those are great questions to get ready for the Kahoot. It's just for fun and for prizes and to learn. So it's on your phone. It's pretty easy. Like, I've had a lot of students be like, how do I play this? And then we jump in and they're like, oh, it's kind of just like a, thing. Can we go over? I think we're doing that here next. You got it. You got it. Peaks right there. How long will the review last? Probably an hour and a half to like just pass out. Just kidding. Hour and a half, I would say. Great questions right there. And so right here with the mortgage, so you see the best way to review the exam is to do yes. And so just briefly on this, and we'll do the mortgage. Here, I'm going to speak briefly on it. Here we go. 201. Just speaking brief. Well, please keep asking these questions. Please keep asking. So we're going to do as much as we can do. When it comes to reviewing for the exam, the Canvas contents are what the test questions look like. But here's the thing. If you memorize all the Canvas contents and then you come to the test, you'll probably get those right. You want to know the concepts behind all the Canvas contents. That's like the number one, the way to ace the test is to, when you see a Canvas content question, be able to come up with your own version of it. Like if I were to ask you, name graphics that we could use to display how tall someone is. How many can you tell me right now if I say name graphics that we could use to display how tall someone is? So think of a graphic right now that we could use to display. If we asked a bunch of people, how tall are you? I ask 100 people, how tall are you? And then what could I use to display that graphic? What can we use? Histogram, Michelle, that is correct. Anything else? Histogram, that is correct. There's some points right there. Dot plot, exactly. Dot plot, histogram, and one more. Yeah. Oh, we could do that. Gabrielle, we could do it. Shreya, close. Not bar plot. Now, so stem and leaf. Because, and let's think about this, and we'll do a quick review. Let me do this. Here, let me make a second section of this real quick. 15, 20. Stat tool 1. Okay, I'm making this a section in the video. I like to switch up the topics. Okay, so when I say that a variable is univariate, when I say that a variable, we're just collecting height, I'm telling you what about the data. If I say we're collecting height, and I want to say a big shout out to everyone answering the questions right there, some points in the chat. If I say we're just collecting height, what am I telling you? If I say we're just collecting height, then I'm telling you what? It's univariate, And it's also what? If I say we're just collecting height, it's univariate. And Michelle got it right there. It's univariate. And it's also quantitative, right? So height is like, how tall are you? So the graphics up there in the top left, you have to look all the way at the screen over there. Right over there, that box is univariate quantitative. This is univariate categorical. If we wanted to make a scatter plot, then that would be bivariate quantitative, the relationship between two variables. If we want a mosaic plot or contingency table, that's bivariate categorical. There's also things like side-by-side box plots and side-by-side stacked histograms. You can actually do side-by-side histograms. You can do stacked box plots. Stacking and side-by-side is just like a vertical or horizontal way of putting them. There's even more graphics than what I have displayed on the screen right here, and we don't talk about logistic regression, and we don't like ring plots. What is logistic? Oh yeah, we don't talk about it in this class. Super quick on that. I can show you. Logistic regression. Sorry, I swallowed my coffee the wrong way just earlier. Logistic regression. Does anyone know? 200 points in the chat if anyone can tell me the difference between linear models and a logistic model. Does anyone know? This is just super quick, and it's important to all the upper level classes. Does anyone know the difference between a linear model and a logistic model? And gotta look at the data set. What is the difference? We need some help from the upper level students. Boom, Noah got it right there. Yep. So the difference is it's the variable type. So a lot of this boils down to variable type. I should do it right here. Oh, it's mad. Wait. Oh, that's fine. Oh my gosh, I didn't put the G. There we go. And so a linear model. So here is a linear model on the screen. Does that make sense? That's a linear model. Now, a logistic model predicts something like the quality of a wine, and a quality of a wine is categorical. So when I visualize this model, we get the logistic sigmoidal curve. Now, it actually goes further out, but this is the sigmoidal curve, and it's not linear. So if you look at a logistic model that predicts the probability of a wine being low quality, it's different than a linear model, which is a line. So the logistic model is a sigmoidal curve, and what's the difference here? The y variable of interest is what? The y variable of interest would be what in a logistic model? So think about what you see right here. The y variable of interest in a logistic model would be what? The y, now we don't do this in 201, but the y variable of interest in a logistic model would be what? It'd be categorical. Great job, Shreya, right there. So if you notice, we have right here in the wine quality data set, you can see right here, if I go to the quality of a wine is categorical. So that's the difference between linear regression and logistic. Linear regression would be made in a what graphic? A linear model would be made in a what? Great job, Christy and Shreya. Let me throw you some points. A linear model would be made by looking at a what? A linear model would be made within a what? So look at this screen. I'm not blocking any right answers right now. But a linear model would be made in a what? That's very important to 201. A linear model would be made in a what? Like what graphic? What graphic would we show a linear model in? There's actually two answers to this. A linear model would be made in a what? What kind of graphic displays a linear model? Scatter plot, Met, you got it right there, a scatter plot. So the scatter plot or a time plot if the x-axis has a time orientation, and you'll be seeing that some of that here in a moment. Well, we might do that next. William had a question, so it'd be a good segue to just show some time plots. So a scatter plot or a time plot, great work right there, Shreya. I don't know how to drink coffee these days. A scatter plot or a time plot can display a linear model for us. And kind of, so keep asking those 201 questions. This is a good review right here, but just think about how we're asking these questions where it's like, how would you display what state someone was born in? So what graphics could we use to display? And so you have to think, state someone was born in. Okay, that's one variable, that's categorical. So how would we display that? These are some of the more basic questions, but we do the easier ones first. So how would we display the state someone was born in? It's categorical. So how would we display it? How would we display the state someone's born in? How would we show that to someone visually? Bar chart, pie chart, Pareto if we want to put it in order. Frequency table is just like the table of how many. So we could actually go back to here, and we'll just do quick ways. Quality of a wine is categorical. So I could go right here and I could just go bar plot. Actually, you have to do a table of it. We won't do a ggplot. So there's a bar plot of it, or we could just do a frequency table. And there's a bar plot and a frequency table. Not the prettiest of graphics. Is it pi? There's no pi. No pi in R. I don't know how to make let's look up ggpi, something like that. Oh, wait. Library. No, I should be able to do it quickly. Let's try this. ggpubr. Is there a ggpi? ggpi. Okay, so I need to take my table, store my table as a data.frame. I'm doing this I've never used this function. We're going to try this. We are trying a function Brian's never used. And ggpi has the format. You can see the format right here. It's got the data and the x. Oh, okay, we got a cheat. You can always look at the instructions on it. And there's the data frame. Oof, they don't make this one look pretty. They're just saying value. I think I show their data. Group and value. There's the group and value. Label it as group. Okay. Okay, there we go. So my data frame has, there's the value, and the value is how much. So it's frequency and variable one. There we go. Oh, it's beautiful. It's beautiful. Where's my help? Ready for some seasonal plots? Yeah, we're going to jump right into that. And let's just throw this right here onto this. And let's remove the palette. What kind of colors are we going to get here? Unknown group. Fill equals this. There we go. There is a pie chart pretty quickly. And what I do love about this, we're jumping into these upper level classes right here really quickly, is we can do the following. It should work. We'll find out. And the answer is nope. Doesn't do it. That's interesting. Doesn't do it. But I'd say we got a pretty decent graphic right here. And then as Tool 1 knows, we can add titles to these, or we should know that we need to add titles to these. And so we would add titles and all that good stuff right here and work on these graphics and make them look really nice. So William, let's go ahead. You had the first question of the day. So Tool 1, kind of start with asking yourself questions. Start with what do I understand about this? What does it mean? How could I quiz myself? Look over the Canvas content and then think about writing new questions from the questions. Because remember, the Canvas content is what the test looks like. And we do pull questions directly from the Canvas content. But the best way to use the Canvas content is to be like, do I understand these? Can I make things from them? And that's how we do it. Let's head back. We're going to do a little 475 and then more 474. But Tool 1, keep asking those questions. Here we go. Back to the next one. Okay, so we got some mortgage calculations right after this. But William was first right here. William, thank you so much. Got some breakfast and ready to go with that first question of the day. You're welcome, Jessica. And thank you so much, everyone, for all those questions. Sometimes I jump the line because Tool 1's got their test tonight. So sometimes I'm like, let's jump the line a little bit right here. Now, the number one place to go, 50 points if anyone knows where to put this in the chat. Where do we go for 201 to learn? 475. Where do we go 475 to get some answers? Where do we go 475? Put the link in the chat. Where do we go 475 to get some answers? Where do we go? Great job right there, Shreya. There we go. I don't know if I have FPP3. Did I say 100? 100 points. What I love, and thank you, all these people putting things in the chat right here. Oh my gosh, look at that. We got so many, we got 3 FPP3s. 3 FPP3s. It's gone meta. There's Rob Hindman right there, and George Athen. Yes, I can't talk. Okay, let's go over here to some time series graphics. Great job, Jessica. So we are talking about these seasonal plots right here. Now, what's really great about this is you have to think, what does this... Oh, you can't even see it. Sorry. That's why we have a confidence monitor. They are opened... Exam 2 is open longer. Exam 3 has to be on the last day of class because I can't push it back because university would be super mad if I push things back. You don't want to cross the university on that. You don't want to say, hey, so I pushed back the last day beyond you have to close your stuff when the class ends. but I did open exam 2 longer. And so, but I can't go beyond the end of classes. Like I can't, the university would be very unhappy with me. I don't like that. Thank you for asking though, Sam. So we see right here a data frame, a function, and then a variable. Now, in truth, this is all we need right here. So let's take this little tiny bit of code. Anytime, Sam. Anytime. Keep asking those questions. Who feels like if you ask a question in chat, Brian's going to see that question? Who's like, you know, if I ask a question, if I jump on YouTube and I got a question, Brian's going to see it or someone else is going to see it. Anyone feel that way right now? So we get some code going right here. Loading up our code. We got bunnies in the chat. Bunnies are back in the main room today. Orkin person's going to come by. Me, Jessica says, I like that right there. Yes, I will see your questions. I will answer said questions. Michelle raises their hand right there. You bet, Jessica. Awesome. Okay. Now, what we need to do, I'm going to do like one of these. Yes. Oh, Shreya is totally right. Please tag me if I don't see it. Sometimes I miss it. It's possible. What we're going to do is we're going to load up a data frame. Now, how do we get to those said data frames? Does anyone know for 100 points how I can view all possible data frames that are currently like freebie data frames? Now, these are not Excel files on my computer, not doing a read CSV. How can I view all freebie data frames on my computer that are currently possible for me? Who knows the function to view all free data frames? We might, Shreya, that is a really good answer. Well, it's not showing me inside the package. Oh, is it? It's FPP3. I don't even know how to type. Actually, Shreya, every point button, that did work. Shreya, that did work. Now, this is not every data set inside of my computer, but this does let me see the data sets inside of FPP3, which is very important. So I can see, can you see which ones are the data frames? It shows you a little picture of like an Excel spreadsheet. So those are just data right there. And great job, Shreya. I didn't even think of that. That's why you get the big points right there. You can also run data and hit random buttons on your computer. You can also run data with an open parentheses. Yes, you need a plan and a prototype for your group too. So be talking to them, have the plan submitted tonight, prototype by Friday. Make sure to have a plan. Say who's going to do what. Good question, Peaks. I found it while last assignment. Yeah, there's so much. And that's so cool, Shreya. I'm just so proud when someone's like, hey, you can do it this way. And I'm like, oh, I guess you can. And if you look right here, I ran data. And does that make sense, Shreya? Right here also, we have it telling me the FPP3 package has these data sets. So you can do it other ways. So Shreya found out a great way right there, and I didn't even think of it. And I was like, yeah, that should work to look inside the package, see what it has on it. So that's awesome right there. So we know what we have access to. We have access to a lot of Australian data, and I think it's already kind of pulled it up and put it on our computer. So these are the Australian data sets right here. Let's go ahead and look at Australian production. Here we go, Aus production. So the Aus production is what kind of data? Whatly data. What kind of data do we have here with Aus production? We'll do 2 of these. What kind of data do we have here with Aus production? Any idea what kind of data this is? We're looking at its quarterly data. That's going to tell us the period right there. Also the index. So you can see right here, the index is on quarter, and then these are the measured variables. So let's go ahead and change the format of this. All we're going to do is put the data set right here. We're going to look at tobacco. And guess what? Here it is. I see a little bit, so try not to do the ones I do. I pretty much like when people don't do the exact ones I do. We'll look at a different format for doing this here in a second, but the code is going to be data frame, pipe into GG season, and then we do want to add on here like GG titles. So we want to go plus GG title, and then like my title. And there it is with that. And then we go plus, and then easy. I might have it go easy center title. And I like to do that. That has to be, you have to have a library, GG easy right here. And now we have a pretty decent graphic. There's more you can do with this. Assignment 3, we just make 5 graphs and explain. Exactly. It's very much like assignment 2. It's just knowing how to look at and analyze time series data. And Shreya, how are you finding these functions right here by taking your data set and then piping it into the next thing and choosing the variable? And then just kind of adding on the extra things like here, like a title, centering the title, thoughts on difficulty. I hope this wouldn't be. I hope you're like, okay, I got this. This is not so bad. I was trying to super easy and fun. Oh my gosh, that's what I want to hear. Like, it's not so bad. I can make some cool graphics. So many options. That's exactly the way I feel about it. It's like, oh, we can do tons of stuff. And what we could do is we could change this and go to GG subseries and check it out. Now we have a totally different thing. Now, if you take a look, it's easier to see the what pattern opposed to here. What is it easier to see? Actually, I might like this even better. And just look at how quickly we changed it from GG season to GG sub-series. We just changed this one argument right here, and we get a totally different plot. What do you notice right here? When you use quarterly patterns, yeah, and you can see the mean of the quarter right here, that Q3 is the highest. A little bit apparent right here to see Q3 is a little bit higher. You can also see that over the years, it rose till about the early 80s, and then it started to drop. Pretty much all of them show that pattern that starting in the late 50s, tobacco was on the rise. It kind of hit its peak in the late 70s and then started to drop off. And all of these graphics, we have 4 different what here. 201, great question. We have 4 different what's here for each quarter. So we have 4 different what's here on the screen. What is the name of this graphic? Because we're looking at tobacco over a year, split apart by quarter, but we have 4 different what's on this screen. We have 4 different what's. We have 4 different what's on the screen currently. 4 different time plots, exactly. And this is what I love. If you get like plots and 4 different time plots, this is what I love about it, is the code is not too hard to do, because watch this. If we wanted to go over here, I will throw 300 points if a 201 student, so give them a second here. How could I instead look at cement with this same graphic? So 201, I want you to think, how could I instead, I gotta say it's a 201 name, so 474, 479, don't say anything for a second. How could I then look at cement instead of tobacco? 300 points on the line right here. How could I instead, because I know a few of them are listening, how could I instead look at cement instead of tobacco? Be like, let's look at cement instead of tobacco. How would we do that? How would we look at cement instead of tobacco? Boom, Jessica. That's all it is. Just change this. There you go. And look at that. Cement's been on the rise. There you go. That's all we had to do right there. So once you kind of get the format of the code, looking at different variables is pretty easy. Like, it's like, okay, we just have a different variable right here. So we just change it right there. And so great work. Shreya, awesome job. An extra 100 points, Shreya, cheering people on right there. We love it. And then we can see cement has been on the rise for years. There's it has some volatility to it. You can kind of see some dips, but we generally see a linear pattern. Cement has a rather steady quarterly pattern, still higher in Q3, lower in Q1. Kind of talking about these things right here to tell people what we see and what we understand. And this is the great thing about data analytics, is we can get, all this stuff pretty quickly. We can just reanalyze the data, whatever we want. We could even go here and go to the call names of this OS production and find out the names of them and just double click and go right here and look at electricity. Ooh, electricity. Ooh, it's got a dip there at the end. But we can make it, we might be able to. So Shreya, good question right there. We might be able to. So we're going to store the object. When you left arrow or right arrow, it's going to store this into X. So now X is my graphic. Like everything I just created right here is now X. That's what the right arrow into X means. So watch, when I run X, I get my graphic. Okay, Shreya, help us out. What could possibly make this graphic interactive? Now that I have my graphic stored into X, now we can't knit this to a Word document because Word documents don't have interactivity, but it is cool. We could put it into a web application. Boom, Shreya, you got it right there. GG, if it's going to work, it's going to be GG Plotly. And the answer is, we've now done it. We have now created an interactive graphic that someone can hover over and see the mean for each point. So there's the y-intercept at each point. It even reports to you the quarters, and we just turned it interactive with that little function right there that just takes the object. So technically you could, this is where it looks messy, if you put everything inside of there, that'll do the exact same thing right here. So that will do, but I prefer to just call it X and then do my ggplotly on it. So I think that's the easiest ways to store your object and do it. Yeah, and it even looks cooler. Like you could screenshot this because I like the the lines are a little bit thicker. So what I would do right here is once you get this nice and neat, I would go ahead and I would just screenshot this in. And I mean, look at this. I mean, if we were to label it, does this look like something you would put into a decent report, like a professional report? Maybe we make it a little bit smaller. But yeah, I mean, I'd say that's a pretty good graphic. You might see that like in a textbook. Pretty easy to read. We might change some stuff on it, but good looking graphics right there. Shreya, 100 points again. But that's what we like to do right here is we like to make good graphics, explain data, and help the user understand. So you're going to make 5 of these plots, try to make them look nice. Some people did lose some points on kind of your screenshotting because the way you screenshot, the way you present it is very important. So we're not here to just create graphics and throw them on a page. We want to make sure that they are explained, they are clear, they are easy to understand. You can just change your title to wherever you want. And I think, because it's just labs, right? Oops. Oh, it did it. Yeah. I forget these. I forget there's so like, so this is how you just change the labs right here. And I think you can say title. I just like GG title. But here's the labs. Here's the X label and the Y label. And so down here we could say years of production. And over here we could say units of electricity. I don't think those are the right things. But now it's just going to change those right there for us and say years of production, unit of electricity. And then we change the title to Australian electricity consumption. There we go. And now we actually have a, I mean, just look at how quickly we're just changing the way the titles are. Oh, and then we want to ggplot it. So let's ggplot it. And there you go. What do you rate this graphic? We'll take a good screenshot of it. There we go. Nice title at the top. And now we actually have titles. I guess we could write quarter. Yours, well, I don't know. It kind of shares the same, but I'd say this is a pretty good graphic. And we just built it from the ground up. I don't like GG Season as much. Yeah, GG Season can look pretty interesting. And watch what happens. We just go over here to GG Subseries and go GG Season. And now we rerun our code. And we get this plot right here. So it's just been steadily increasing. You can see these steady increase as you go up right here in years. Or stay decrease. Wait, what? Ooh. Oh, it says the IDs are wrong on this. So that's a problem. It doesn't look as pretty. Do you want all of our plots to be... they don't have to be. Good question, Thomas. They don't have to be. It has to be 5. Yes, make sure. Well, you could do a sub-series, and it has to be 5 different plots. But you could do a sub-series and a GG season of different data, of the same data. You just have to do 5 different plots. Preferably, yeah, because it might not be interesting if you do the same data. But it's more the goal of this. Think about the goal of this. Can you run these functions? Can you interpret these plots? So does everyone see my goal right there real quick on this? And we're going to jump to 474. But my goal for 475 right now is, can you run these functions? Can you interpret these plots? Can you put them in a document nice and neat for somebody? Those are like the 3 objectives. Be able to run the functions, be able to interpret the plots, and be able to put them in a Word document so that they're nice and neat. So a few people lost points on kind of the screenshotting of the graphics. Make sure they look nice and neat. Don't catch any borders of stuff. If you do catch extra things, you can always click this and go to crop on it and actually crop the image inside of Word to remove any sort of extra. Just make sure it looks nice and neat, like you're going to turn it into the business and be like, hey, here's our quarterly reports right here on the data. As you can see, rather static throughout the quarters, but we have high increase. Of course, in recent years, we're seeing a large dip at the end, especially at Q3. We don't know if that's just an aberration, but it is kind of our most volatile downward shift we've seen in recent periods. That really catches my eye right there, and that's how we talk about data. Well, let's do some 474. Keep asking those questions in the chat. You're welcome. Awesome work, Shreya. Everyone know, what day is it? Crash knows what day it is. Mewbot appearing on those wacky Wednesdays. Okay, let's get some 474 going. Gonna pull up the lab data. Everyone knowing it's Wacky Wednesday. Gotta remind me in class, be like, Brian, it's Wacky Wednesday. That is like the number one day. Wow. This is the number one day. I made those. I made them a while ago now. And now, yeah. Wacky Wednesdays. Let's take a look. People were wondering about, oh, we gotta do the mortgage, right? Okay, let's do mortgage first. Thank you, KP. Okay, let's do mortgage. How to talk about mortgage. That was next on my list. So, I was thinking lab. I have a 2-1 question. Are we going to have any questions on the David and Lane Applet? Pictures. Know how to look at the pictures and the Canvas content. The questions on the Canvas content that show you pictures are the number one way to know what the test looked like. The questions on the Canvas content that show you pictures, number one way, and we'll take a look. No, I might have to answer that via Discord. We'll go to the main screen. One button. Okay, let's talk about a little mortgage calculation. Thank you, Noah, and everyone for all those questions. Ball means. Okay, so here we go. When you're calculating a mortgage, what's the first thing you should know? If you're going to go buy a house, what's your first kind of question to me? You're going to go buy a house. What might you wonder? Let's think about this. You're going to buy a house. Just walk through this idea with me. What are you wondering? You're going to buy a house. What would you ask? House price. Boom. So let's say price. Let's say mortgage amount. How much are we mortgaging? Kind of how much can we, these are the big questions, right? Like how much can we afford? How much can we get a mortgage for? So that's going to be a big thing. So let's say we're going to get a mortgage for, go back 10 years. And if I said like this amount, people would be like, you want $500,000 mortgage? They'd be like, you're crazy. You don't need $1 million house. And now houses are interesting. We'll call them that. Interesting. Prices are interesting. We don't like interesting. Sometimes we do, but not today. So we're going to get a $500,000 mortgage. So now when it comes to it, how do you get rid of a mortgage? How do you get rid of a mortgage? How do you make your mortgage go away? How do you make your mortgage go away? How would you make your mortgage go away? How do you make your mortgage go away? You make payments on your mortgage. You pay it off. So let's go here to payment. How much are we going to pay on our mortgage? You know, I'm gonna pay $100 on my mortgage. So what we would do right here, I want to do a little bit of work on this. I don't want to do too much, but give some hints right here. I'm gonna pay $100. And so what we would have right here is I'm gonna pay $100 on my mortgage. And so you can say things because you might see the issue here. Start thinking about the problems with this right now. And I'm going to say, let's say amount at period 1 is equal to mortgage. Okay. And I didn't initialize amount. Okay. Help me out, 100 points. It's legendary. What do I need to do? It's giving me an error right there. Fix the error. I do that all the time. I wish it just knew. Just make that object for me. I do that. It's probably my most common error. Boom. Noah knows it right there. Great job, Noah. We're going to initialize a blank object, then we can store into it. So it was, man, great job, KP right there. We have to create the object we're storing into or it gets mad. It says, I can't store into that. That doesn't exist. There is no amount to be found. So we initialize the blank object with a blank vector. So that's what the C concatenate means. It says make something with nothing in it because C is a vector and then there's nothing in the vector. So we're storing now into position 1 that it now exists. We're storing the mortgage amount. Now in position 2, what are we going to get for position 2? Well, position 2 will be my mortgage amount minus my payment. Okay. I'm trying to think of where to stop on this. Okay. So now, this is a huge hint, and I don't want to, this is crazy big. Okay. Now I want to see how long it will take for me to pay off the mortgage. So I want to keep taking off money while this is over, and don't worry that it might go a little bit over, not the end of the world. I mean, our last payment, they might refund us a certain amount. We could even put that like you're refunded this amount. I could make it say that. Are we calculating how long or what your payment would be? Correct. We're going to say how long. I think that's what the function says, like how long it would take to pay off the mortgage with this amount. But there's a very important thing we didn't do with this that I'm going to leave out because I don't want to do the full thing right here, but I want to give some hints for this because there's a huge problem with this right now, which you're probably seeing, which the answer to this is going to be interesting. So the assignment is that the person is going to be paying it off with this amount. So I know usually you get like a 30-year mortgage. I'm going to pull up the assignment right here so I can show people. But the assignment is that you're paying off with a certain set amount. Let me go grab it right here. 2 seconds, pulling up the assignment so I can show it and talk about it while we're doing it. Here's the next one. Our customers want to understand how long it'll take for them to pay off their mortgage. We need to know the amount of the mortgage and their monthly payments. The function should stop if the user doesn't put in a large enough amount of money to pay off the interest and decrease the mortgage over time. The function should return a graph showing the mortgage decreasing over time to the user. Okay. So obviously I was trying to point out the thing we're missing. Like I said, there's a huge problem theoretically. Christy, seeing it right there. There's a problem, right? This is not how mortgages work right now so far. Okay. So what do you think I'm going to start to compose now? Because I can find how much the amount of our mortgage is. The initial, we could call this like initial amount. Might make more sense to call that initial amount. Who's following with me on this? Does that make sense right there that we have initial amount? Do we have how much we started with? So what do we want to do now? What do we want to do now? Kind of. But now we want to start just running a loop to start subtracting on it. Well, check this out, because I could take my, see now, gotta be careful. We want to go to, we don't want to go to initial amount. Want to go here. Yes. There we go. Does that make sense? I did something really quick there. I want to pause because the amount at time 1 is your initial amount. The amount at time 2 is how much you ever had at time 1 minus your payment. The amount at time 3 is how much you had at amount 2 minus your payment. Is this making sense theoretically? Like, who follows along with what's going on with the code right here? I'll repeat it again. We took out a mortgage of $500,000. We're paying $100 on it. We initialized a blank vector. The amount we have at time 1 is our initial mortgage. Then we're going to wait a month, and this is the start of month 2. It's going to be how much we had at month 1, which was the initial amount, because that is the initial amount, minus the payment. Why did I change it to this format right here? Who can explain why, if you're in 474, why I changed it to that format? And you can start to see it. He's just going to chill out right there while I show you the reason I changed it to this format right here. Why did we change it to this format? Who knows why we changed it to that format right there? No worries. Hello, Layla's cat right there. Skeleton for the loop, right? So this is our skeleton. So now we need a condition. Now we need a condition. We need to think about how this works in a loop, and we need a condition. Let's go right here and call this, let's grab one of these, and we're going to say while. When are we going to keep running this loop for? We're going to keep paying off our mortgage while what? The amount of the mortgage is what? When would you keep paying off your mortgage? Just don't even think stats words. Close KP. So you're saying keep paying. There we go, Kirsten. Great job right there. We're going to keep paying off the mortgage while the amount of the mortgage is greater than 0. Does that make sense? While the amount of mortgage is greater than 0, keep paying off your mortgage. So then we're gonna run the code. Great job, Michelle and everybody right there. We're going to run the code that keeps paying off the mortgage. So while the amount of the mortgage is greater than 0, keep running the code that pays off your mortgage. That's what we're doing theoretically right here. So we go inside of here and we run this right here, but it needs to become a loop now. So the while loop doesn't have a variable. So we need to go here and we need to call this I, and 1 will become what? If 2 is I, 1 will be 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 what? I minus 1. Exactly, good work. See right there. I minus 1. Okay. We're going to remove out all this right here. And we're going to say I save into 2. Now, there's a huge problem with this. Hopefully, I don't crash R. There's a huge problem with this loop theoretically right now. Oh, let me go right here. Position I minus 1. There we go. That's another problem. This is the problem I expected. So we're looking at how much we had last period. And it says, while how much you had last period is greater than 0. So what's going on right here? My computer actually started spinning. That's bad. So what's going on right here? This is the problem I thought I would have. So it says, while our last amount, how much we had last month, because we're at this month. So we say, do we need to pay off our mortgage this month? We look to how much we had last month, and then we pay that off. So while how much we had last month is greater than 0, because that's the position before in the vector, while how much we had last month is greater than 0, make a payment. It's not because it's 100. It's because it's not changing what is. It's because this loop does not change what is. It's because the loop does not change what is. So good guess right there, KP. It's not because it's $100 we're paying off. Now that is true for the way the assignment will go when we make the proper function, which are the proper variables. It's not the amount. It's because I never changes. We've never changed. We're not changing what I is. So let's go right here and say I and store what? How would we move I forward 1 position to like advance it to the next month after the loop runs? And that just says, we're going to say, while how much we had last month is greater than 0, make a payment this month, and then go to next month. Exactly right there, Kirsten. Go to next month. So we're going to do I plus 1. So this says, now go to the next month. Like, so while how much we had last month, so we're going to be like, okay, it's this month. When we got the bill last month, did it say we paid it off? Okay, no, we still have things. We still have mortgage. Okay, so we're going to make a payment, and then this is how much we have this month, and then we're going to advance to the next month right here. So we're going to find out how much our amount that we owe is. Then we're going to advance to the next month. And then we say, okay, how much did we owe last month? And we move it forward. So now if we run this right here, it runs. And how long did it take me to pay off my mortgage? It took me 5,000, 2 months. That sounds about right. Sure. I'm trying to double check theoretically right here. Because I starts at 2. And let's go look at the amount vector. Let me go tail amount. There it is right there. Yep. And the amount vector is a vector of, oh no, it actually, so we could be really smart on this. What we could do is we could say if, will an if working, sometimes while loops get a little mad. If amount, if tail amount, comma 1, the last position, equals or less than equal to 0, then break. Lowercase break. Let me see what this does. Okay. There we go. It's a little fancy thing inside there. What did this code? I haven't shown you this yet, but what does this do? What does that do right there? It says if the last value in the tail is less than or equal to 0, then break. What does that do? It breaks the loop. It just stops it. So that stops on that last run. That stops the I from moving forward. Does that make sense? So that we could just do I minus 1 at the end. We could have it report. There's a lot of ways, like theoretically, to do this. Like you could afterwards say, you could cat and say, it took you, I use cat paste rather. You could say cat paste, it took, and then we could say I, and then years or months. So it took I months. We could say this right here. And if we didn't have this code inside of here, we could just run it this way. This is, oh, we got to do I minus 1. That's what I meant to do. So it took that many months. So this is why I want people to think of different ways to do stuff. I don't always like seeing the same answer, because you don't have to do a break. You could just have it, say, okay, so it went and moved I forward after we had made that payment. So if I want to find how many months it took, I could then subtract it off, or I could write a code that stops the loop from running it. What questions are there right now? This is a good bit of the assignment right here. The only major problem is one, it's not a function, which we can make it a function pretty quickly. And two, we're not handling interest. And then if we have interest, there's going to be a problem on this, because with interest, we're going to go underwater. So to check to see if you were to be going underwater, you'd want to see what? You'd want to see, this is the way to know if you're going underwater, is if amount at current position is greater than or equal to amount at what? How would you know you're in trouble with your mortgage? How would you know you're going the wrong way on your mortgage? How would you know you're going the wrong way on your mortgage? If amount at current position is what? Like this is like this month. How would you know you're going the wrong way on your mortgage? If amount, so you'd want to like stop what you're running if this is the case. You'd want to put in some sort of stop or check or look into this, or like a calculation to start. If amount at current month is what? Greater than or equal to what? Last month right there. So we would look at last month right there. So we could look at and say, is the amount at current month greater than or equal? And that's giving an NA. Let me see where the amount, because I think we're outside. I is equal to this. Oh, because we're outside, yeah. So if we ran our code, let me run it this way. It would be fine on the first run. Let's show it on the first run. After the first, there's the initial amount. Okay, we'll run it with the break, because that will actually let us look at the last code. And so we run this. Let me reinitialize the amount vector, because it's going to get mad about that. And then this would say false right there, because it's looking at where we are currently at, and we're currently at 0. And then it's running this right here and saying we had $100. So we are going the right way. What questions are there? This was a good bit of work. This is like one of the use some of this code. I don't want to show too much more, because I want you to be thinking about how to build this, because we're missing the interest portion, which is huge. That's a big thing I left out. We're missing the interest portion. I didn't turn it into a function. Any other questions right now? We're going to try to do at least 1 or 2 on the lab now. But any questions on this? What are people's thoughts? Drop those thoughts in the chat. Let me know while I drink my last bit of coffee. Last coffee from Mr. What are your thoughts? It's coffee grounds in here. Bro, what choked on? What are your thoughts? Who has thoughts? Let's get a lab going. Good stuff. Good work on that right there. Ooh, coffee grounds. I didn't know if that was like an ooh for coffee. Ooh for coffee in the chat. Lab question 2. Lab question 2. 5935. I did my based on an immortalized table and I got it to work, but I can't figure out how to show the numbers of the years from there. Sierra, message me yours, and I'll help fix up those little things right there. Great work. I'd still like to know if it's possible to get desired output with my current code. Yes, no, definitely. I might have to answer that. We'll try to end office hours on time today. Usually supposed to end at 11:45. And then I'll try to jump in and see those messages. And Kayla, yep, number 2, that is what we have next. Make sure I got the right timestamp on here. Okay, we're at the 1 hour mark. Let's do lab number 2. Here we go. Okay, it's time for lab number 2. Thank you, Noah, so much. Yeah, especially when it comes to people's individual code, I want to kind of make sure, like, they get, your code, your work, want you to see it, and you got it peaks. I think we'll be able to do number 5. Function with if, for, or if else. Write a function called party that takes a vector x and returns a character vector, not a factor, of the same length whose elements are even if corresponding elements of x is even, and odd if corresponding elements of y is odd. Hint, A variable number is even if, there we go. This is modulo. It's the way to check it right there to see, is it divisible by 2? And if it's, or the remainder, sorry. Is the remainder of 2, and then is it equal to 0? So we're finding the remainder of the number. Such as if you were to run this down here and you were to put something like 8 in here, 8 has a remainder of 0 when you divide it by 2. You can also see if you do something like 10 modulo, I think that's how it's pronounced, 3, this would equal to 1 because you go 3, 6, 9, and then it has a remainder of 1. So it's just telling you the remainder when you divide it by that number. Show what your function returns when you pass through dataset known about the default. You can print to the screen. Okay. Called parity. Turns a character vector of the same length. Yeah. There we go. Okay, so we're just trying to check if something is even or odd. Okay. So let's do it. Write a for loop. Okay, the easiest way to do this is with an if else. If you choose to write a for loop with an if statement, yeah. So it's actually pretty quick with the if else. Like if else is so much quicker. So let's show how to do it with an if else. So we've got right here the vector mtcars HP. So we're just trying to find out if these numbers are what or what. What's the point of this question? Just describe to me. The point of this question is that I should turn this into a character vector that just says what and what for all these values. All this does is telling us if these numbers are what or what. All this does is tell us, are these numbers what or what? All it does is tell us, are these numbers even or odd? So check it out. You ready? If, else, and let's put the vector inside of here. And then the vector inside of here is going to be, is the vector number divisible by 2? So is the vector number divisible by 2? Well, that's how much, excuse me. And is that amount equal to 0? So this will give me what's and what's. If I run that code I've highlighted, that'll give me what's and what's. If I run that code I've highlighted, that will give me what's and what's. So think about what that will return for me now. If I run the code I've highlighted right there, that'll return for me what's and what's. If I run the code I've highlighted, that will return what's and what's. Trues and falses. Great job, Kayla, right there. It will turn trues and falses. Now, if it is true that it's divisible by 2 and the remainder is equal to 0, we're going to write even. And if it's not, we're going to write odd. And there we go. But this isn't a function yet. This isn't a function. This right here is just a specific case. So let's take this and write, F is for friends, do stuff together. You know the rest of the song. We write fun right here, and we take and drop the function inside of here, or the code inside of here, and we change this to something like vector. The vector we put inside of here, and we put the vector right here, and we call this parity. Let me pause. Questions on what I just did? What I did is I created a function snippet by typing fun, and then I named the function parity. So this is the name the function is being stored into. Then I specified a variable that someone will input. So whatever input here will go into the function. I guess we need one more thing. For 100 points, usually you should do this to end your functions. So think about what my function should take now to end it. What should my function take now to end it? What should my function take now to end it? So what should I do with my function now to end it? Return. Great job right there. Yup. Wrong button. There we go. The parity function now works. How's that looking? Pretty good. Because with a if else, it's not as fun. With an if else, it's not nearly as fun. With an if else, it's not nearly as fun. We need to go to mtcars. We need to go to HP. We need to go to the first instance of it. And we would say if this right here is divisible by 0, then run the following code. This is another way of doing it. If mtcars HP, the first position, it says vector object not found. Send him to me, Kayla. It should do it. Send it to me, and I'll take a look. Send me the code and I'll take a look. It should, the code works right here. Let me know. And we'll do it this separate way here. We'll do it with the if and else, which is a lot less fun. So if empty cars position 1 is, when we divide it by 2, if that remainder is 0, then we're going to go here and say store into, let's call this answer. Store into answer position 1, store into that even. And then we go right here and we say else, store into answer 1 position odd. Now let's look at answer. There we go. Now, what do you think I've written right here? I said if empty cars position 1 is divisible by 2, well, the remainder of it when we divide by 2 is 0, store into answer vector position 1 even, else, because if it's not, then store into answer position 1 the word odd. What do you think I'm going to use this for in a moment? This is the longer way of doing it, which I wouldn't. Nice job, Kayla, right there. Good work. Yep, those capital. And one way to do it is to highlight it and to see if it highlights. So, like, that's a really good check right there. I should have realized that. Great work, Kayla. What do you think I've done right here by just doing the first thing right here where I'm just creating one version of what I'm going to be doing? I'm doing what? Skeletor is pretty strong. He's like, I don't know. Need to do as many push-ups as Skeletor. So we have created the skeleton. So the skeleton right here is just going to change the number. So now we want to take this code right here. This is the long way. So that's why I'd be like, don't do it this way, in my opinion. So here's the for loop right here. I'm using Control-Shift-A to reformat the code a little bit. And we want to go with position I. And we want to go 1 through length. Whoops. 1 through how many values there are in empty cars $HP. There's right there. So we now put it inside of a for loop. So now it's inside of a for loop such that we have the for loop is using I to iterate through the elements, the first through the last positions in how long the empty vector's car is. Now, like I said, the first way of solving this was so much nicer. Now we're going to take this and we are going to put it inside of a function. And this is actually the easy part. The easy part of the function for this is going to be that we write our function snippet and we open it up, and with it, we're going to drop inside the code. Now, what do I need to do? Look at the similarity between what I have on the screen now, and here we'll delete off this, but look at the similarity between what I did up here and what needs to change. Like, we need to call this parity, and then we need to do what? What does my function take to run? It's going to run the same way. What does my function take to run? What does the function take to run? The function would take a vector. And so great job, Kayla, right there. It takes a vector. And then at the end of the function, which is going to be here, we're going to go return and answer. There we go. So we'll return that answer. And we've done it. There it is right there. So that much longer way of doing it. There's the same way of doing it. Does that make sense? Preferably, I'd use the if-else because you don't have to worry about the for loop then. But we did this two separate ways right here. One with the if and the else, and then the other with the if-else. So the if-else was much quicker. And then we always get it to work on one instance before we put it inside of a function, because then all we're doing is just taking this right here and turning it into the input of the function to get it to work on any instance. It also wanted me to do it on a specific vector. So I was like, well, let's just do it on that vector and see if it works. So yeah, we've got another one. I think we can do it really quickly here. Question 5. Okay. Question 5. Let's scroll down to it. Our first topic in data mining portion is clustering. We're about to get into that soon here. Similar individuals or group. How do we find similar as a choice? And we rely heavily on the distance between individuals to guide our analysis. Previous labs have explored a few different distance matrices, but all have assumed each individual can be characterized by a set of numbers. What do we do if we have a categorical variable? If someone is 5'8" and has blue eyes and is from Tennessee, I think strawberry is the best ice cream flavor. How far away are they from someone who has these characteristics? One way to calculate a distance between two categorical variables is to simply count up the number of values that are different. So we're going to look down here at two vectors right here where we have vector 1 and vector 2 of males, and we have a male, we have a female, they're from Tennessee. So we're going to see how different they are. So just look at this right here visually and tell me the amount we should have for how different these individuals are. So just tell me visually what should we do to calculate, or tell me the answer for how different are these individuals based on their categorical variables. As in, they're both born in Tennessee. Boom, boom. They're both unmarried, unlike me. So that's a good thing. Well, for me, not for them. How many differences do they have? How many differences do they have? These individuals have how many differences? He's like, man, I love me some Adidas. All day long, I dream of soccer. And she's like, nope, I'm Nike. And they say, we're not interested in each other. That was the defining reason why they were. This is like everything. So 3, right? 3 differences. And you can see it right here. Middle child, like me. Only child, like my wife. Ask her if she likes Nike. We're not from Tennessee. Male, female right there. Okay, cool. So how about this? V1 equals, I know, V2, humble. Which, this vector shows if they are what to each other. This vector shows if they are what to each other. This vector shows if they are what to each other. This vector shows if they are what to each other. If they are what? Just explain to me what that is showing. That shows if they are what to each other. That vector shows if they are what to each other. Like on line 149, if they're the same. How could I see if they're not the same? How could I see if they are not the same? So that shows us if they're the same. How could I see if they're not the same? How could I see if they're not the same? Not equal. How could I find out how many not equal characteristics they have? How could I find out how many not equal like, I want to know how many characteristics they have that are not equal. How could I find out how many characteristics they have that are not equal? How could I find out how many of those things are not equal between them? So that's if they're not equal. So they were not equal on the first one. They were not equal on the first one. Because I was like, it's true that they're not equal. It's false that now I go sum of it. Great job right there. So even I'll confuse myself. There we go. So now we have the sum. So they're not equal on 3 things. Great work right there. Kayla and Kirsten right there. They were not equal on 3 things. And Grant, good practice right there. So they're not equal on 3 things. So now we want to take this right here. And let's go out here. And go in and go fun. And we're going to go right here and put the return on this. And now, do we already have? Yeah. And then somebody puts that in. We should be good. There we go. That's got it. Does the association only measure the strength irrespective of the graph being linear? Matt, good question there, Matt. 201 question. So in 201, if you're talking about regression, regression assumes a linear association. So can things have, this is to Matt's question right there. Can things have a correlation of 0 but have a relationship? So can things have a correlation of 0 and have a relationship? Can things have a correlation of 0 and have a relationship? Yes, Layla, great answer right there. They can. So a squared plus b. Wait. Let me see right here. Oh my gosh, my brain. Okay. Here we go. 3x squared plus 3x minus 2. I don't usually have to do algebra. I don't have to do algebra. I tell people that's one of my other commenters right there. Not usually doing algebra. Plot y tilde x. And take a look. We got a parabola right there. But if I look at the correlation of this graphic, the correlation of this is probably going to be close to what? The correlation is, it's not perfectly that. How strong is the relationship on here on this graphic? How strong is the relationship with this graphic and these points? How strong is the relationship with the graphic and these points? How strong? What? I don't like general plots. How strong is the relationship? How strong? Oof. How strong is the relationship? It is very strong, and it's nonlinear. Great job. Nonlinear is the form of it, so it's very strong, but it's nonlinear. So that is a very strong relationship. It's nonlinear, and that's why correlation is coming back close to 0. So the correlation being close to 0 right here, and also the p-value for correlation is high, telling us that the linear relationship here is likely due by random chance. So there's a quick stat to one topic right here. The p-value is high, suggesting that the linear relationship is probably due to random chance, but this is an extremely strong parabolic relationship. Now, what we could do in our upper level classes, and this is why I love this, is we could store this as a model and watch this. If we were to look at just the linear model, we wouldn't see it, but we can actually look at the nonlinear models. So looking at the nonlinear models, we actually get an r squared adjusted, don't worry about r squared adjusted, of 1. So this goes to upper level classes, but we don't have to fit just a linear model. We can actually fit the parabolic model right here. And if we want to make this look a little bit nicer, we say something like on this max order, I think it is the argument, max order equals 2. And now we can see right here that the parabolic model actually has an r squared adjusted of 1, and that means that the parabolic model explains all of the data. Does that make sense, Matt? We kind of jumped into an upper level class a little bit right here, but the linear model doesn't really explain the relationship. The linear model is not really what's going on right there between these points. The parabolic model, which would be a polynomial model, actually explains 100% of the variation because it was literally generated from that. And so, yep. So there's a very strong relationship right here. So there's a strong association, but it's not linear. And that's why we're getting correlation values. I thought it said the correlation was negative. No, the correlation is positive. Correlation is positive. Because I was like, if the correlation is negative, the line should go down. There's very light positive correlation right here. And you see that right here with the value of correlation. But there's a super strong association between these points. So association just talks about a general idea of knowing X tells you something about Y. There's a strong association. It's not a linear association. It's a parabolic association. If you were to do r squared, and this is r squared adjusted, I'm not going to go into that. R squared adjusted can go negative, 320 topic. But if you were to do the r squared here, you would see that r squared for the polynomial model is 100% because the polynomial model explains 100% of the variation. Great topics met right there, and it really branches into some really big ideas that we use later on. So until then, we're going to get ready here for some 474. See everyone soon. Bye for now. Bye.